most developers have done this. We create .env file, we add database URL, we add JWT secret, sometimes maybe an API key as well. The application starts working. So we think everything is fine. But after some time, the same file is on multiple laptops. Another copy is in CI/CD, another copy is in staging, and one more is in production environment. When one secret changes, nobody is fully sure which application is still using the old value. This is where the real problem starts. The problem is not that we are using environment variables. The problem is how we are storing, sharing, and updating those values. In this video, I'll remove the local.env file, start the same exact application without changing any application code, and then use Infisical to inject the configuration. After that, I will update one value inside Infisical and show the application picking up the new configuration. Let me first show you the current setup. This is a very small FastAPI application. It needs 5 configuration values. For example, in secure demo.env, here we have 5 different environment variables with its values: database URL, JWT secret, payment API key, and the secret version. This secret version is the safe value which we will use later in the demo. These are only fake values for this local lab. Now, there is nothing wrong with the application reading environment variables. That is completely normal. The issue is this file becoming the way we distribute secrets between developers and environments. Now I will load these values into the current shell. Set-a exports the variables, followed by source insecure demo.env loads everything from this file, followed by I will use set plus a stops the automatic export. Now the shell has all the application secrets. Let me start the application now. The application is running. We are going to leave this terminal running, followed by I am going to jump back to other terminal, and let's check the health point. The process is healthy. Now let us check whether the application is actually ready. The application is ready because all the required configuration is available. Now I also want to verify the configuration without printing any secret values. We can see all the required secrets are present, but we are not exposing the actual values. Right now, the application works, but it works because I manually loaded the secret from a local file. This file is one copy. The shell is another copy. If I send this file to another developer, that becomes one more copy. This is how the secret sprawl starts. Now I will stop this application and I will remove all the application secrets from the shell. Let us confirm if they are gone. Application secrets are not present. Now I will start the same application again. No code change, same command. Only difference is that I am not loading the .env file. The process started successfully, but is the application ready? Let's check that by confirming in the other terminal. The process is live, but the application is not ready. This is something we also see in real production environment. A process can be running, but the application can still be unusable because configuration is missing. Nothing is wrong with the application code. We simply removed the only source it had for getting the required values. Now, the question is, how do we give these secrets to the application without sharing the .env files everywhere? Before installing any tool, let us define what we actually need. I do not want developers sharing .env files. I do not want secrets to be committed to Git. I want separate environments like development environment, staging environment, production environment to have separate values. I want the application to use managed identity. I want proper access control. I want to know who changed a secret and when. And most importantly, I do not want to rewrite the application. The application should continue reading normal environment variables, only the source should change. Now we have a real problem and clear requirements. Only now it makes sense to look at a solution. One platform that fits this use case is Infisical. But I do not want to present Infisical as just another place where we paste secrets that does not solve much. The useful part is that we can separate environments, control access, use machine identities, track changes, and inject secrets into the application when it starts. For this demo, I am using Infisical for one simple purpose. The same application should run without reading secrets from a local .env file. I have stored the same 5 keys in development environment. I am keeping these values hidden. The application does not need to know where Infisical stores them. It only needs to receive the values it is allowed to access. The next question is authentication. I do not want this application using my personal Infisical account. A workload should authenticate as a workload, so I created a machine identity. For this local demo, I am using universal auth. Universal auth gives us a client ID and client secret. The machine uses those values to get a short-lived access token. Now, someone may ask, if Infisical stores our application secrets, where do we store the client secret needed to access Infisical? That's a valid question. This is called bootstrap problem or secret zero. For this local demo, I keep that credentials outside this project repository and restrict access to the file. That is fine for local demonstration. In production, I would prefer OIDC, Kubernetes authentication, Azure workload identity, AWS IAM, or another native identity method. So the goal is not to pretend there is no trust anywhere. The goal is to reduce the number of long-lived secrets and control where that trust starts. Now let us run the same application through Infisical. No code changes, no local application secret file. The application will still read normal environment variables. Only the source is different here. The Infisical CLI authenticates using machine identity. It retrieves the values this identity is allowed to access. Then it injects those values into UVCon process. From the application perspective, nothing has changed. Only the way the secrets are delivered has changed. Now let us verify the application. First, I am going to start with the readiness check. The same application is ready again. Now let us check the configuration status. All the required values are present. The application code did not change. The command starting the UVCon is almost the same. What changed is the way the secrets are delivered. Before, a developer loaded them from a local file. Now, Infisical retrieves the authorized values and inject them at runtime. That is the main difference. Now, let me show one small update. Now, the application is running with watch command. That means Infisical can watch this environment and path for changes. Let us check the current value. Here I can see the secret version as V1, environment is development. Here I am going to update the secret version from V1 to V2. Save this. I changed the version from V1 to V2. Now was the application terminal. It shows the process restarting. Infisical detected the change. It stopped the child process. Then it started the application again with the updated environment. Let us verify that value real quick. Now the application secret version reports version 2. I did not edit a local .env file. I did not change the application code and I did not manually restart the UVCon. The configuration changed centrally and the application started getting with the new value. Let us be very clear about what this solves. We no longer need to share the application .env file as the source of truth. We can separate development, staging, and production environments. We can use a machine identity. We can control who or what can access which secrets. And we can see when the values are changed. But this does not mean secrets never exist in memory. The application still needs to receive the values, and this does not mean Infisical automatically rotates every database password or third party API key. If a password changes in the real database, that side of rotation must also be handled. So, Infisical is not magic. It gives us a better way to manage identity, access, environments, and secrets delivery. I kept this video focused on local developer workflow. The same approach can be extended to CI/CD pipelines, Kubernetes, cloud workloads. In Kubernetes, we can use Infisical operator. In CI/CD, we can use OIDC. In Azure cloud, AWS cloud, or any other cloud, we can use native workload identity. The dangerous part of a secret is not only the value itself, the real problem is how many copies exist, who has access to them, which environment they belong to, and what happens when the value changes. In the first workflow, the application worked because I manually loaded secrets from a local file. In the second workflow, the same application received the authorized configuration from Infisical through a machine identity. This is more than hiding a password. It is a better way to control identity, access, environments, and the complete secret lifecycle. And that is how I would evaluate any secrets platform, not by how quickly I can create one secret, but by how safely developers and applications can use and update secrets across different environments. Thank you for watching. I'll see you in the next video.